Good morning, students. Today we have to do nomenclature of coordination compounds. Okay, when we have to study the chapter coordination compounds, we must be fully aware with the way these coordination compounds are named. Okay, it is very important to understand the subject. Students, let us learn the nomenclature of coordination compounds. Now, the first step in the nomenclature is that we have to name the cation first of all, and this has to be followed by the name of the anion. It's a usual practice. Supposing if we have to name NaCl, we first name the cation sodium and then we name the anion chloride. Okay, so in the same way, while doing the nomenclature of coordination compounds, we have to first name the cation. Now, I have given you some examples, and in these examples, I have written the cations in red ink. Okay, in the first case, it is the potassium which is the cation, so we will write potassium, and then comes the name of the anion, and anion is coordination entity, so we have to discuss, then we will name the coordination entity. In the second example, the coordination entity itself is a cation. So first of all, we have to name the coordination entity and then we will write chloride because chlorine is the counter ion and it is present as an anion. And then the third case again, the coordination entity is the cation, whereas chloride ions, they are forming the anion. So we have to first name the coordination entity because it is cation, and then we have to name the anions. In the fourth case, mercury is the cation, so we have to name it first and then we have to name the coordination entity. I think it is very clear to you whether the cation is an atom, whether it's a group of atoms, and whether it is a coordination entity. So we have to name the cation first and it has to be followed by name of the anion. So the second step is we have to name the coordination entity. So we have to learn how do we name the coordination entity which is written in the square bracket. Now in this, first of all, we have to name the ligands. In coordination entity, a metal atom or ion is present along with various ligands. So we have to first write the names of various ligands, and after writing the names of various ligands, we have to name the metal atom or ion. Now how do we name the ligands? Do we have to follow any particular order? Yes. We have to write the names of various ligands in an alphabetical order. You already understand what is an alphabetical order. And after this, I have to tell you that the ligands may be negatively charged, ligands may be neutral, ligands may be carrying some positive charge on them. In case any ligand it is negatively charged, we have to change its name. So what we have to do? We have to put a suffix O at the end of this, the name of the ligand. Suppose it is chloride, so we will write chlorido. If it is bromide, we will write bromido. That means when the ligand is carrying any negative charge, their names have to be changed by putting a suffix O. And if the ligands are cationic, that means carrying a positive charge, for example, nitronium ion, nitrosonium ion, right? And if the ligands are neutral, right, then we have to, we don't have to change their name. We will write their names as such. The names will remain unchanged. Now, however, there are certain neutral ligands for which we give special names. I have given examples. Some examples are, if the ligand is a water molecule, then we name it as aqua. So aqua is a special name given to the ligand water molecule. Similarly, if there is a ammonia molecule present as ligand, then we have to name it as amine, AMMINE. Be sure that the spellings are double M. Okay, so we have to write it as amine. If there are 6 ammonia molecules present as legend, we will say hexaamine, AMMINE, right? Similarly, if the legend is CO, we have to name it as carbonyl. If the legend is NO, we have to name it as nitrosyl. So some special names have been given to certain neutral legends. So next is, if there are more than one legend present of the same kind, okay, in that case we have to tell the numbers, we have to indicate the numbers. If there are two legends, we will say di. If there are three legends, we have to use a prefix tri. If there are four legends, we will use the prefix tetra. That means if there are 6 ammonia molecules, we will write hexaamine. If there are 4 water molecules, we will say tetra aqua. So you have understood that if the number of legends is more than 1, we have to use prefixes like di, tri, tetra, etc. Okay. Now there is another important thing. Sometimes there are certain legends which have got some numerical prefixes in their name itself. For example, ethylene diamine, its name is ethane 1,2-diamine. Now it is already containing some numbers 1, 2 in the name itself. In such cases, if we have to indicate the numbers of legends, we will not use di, tri, tetra, etc. In that case, we will use bis for 2 and tris for 3 legends and tetrakis for 4 legends and so on. And another important point is, such legends, the names of such legends, they are always enclosed in brackets. Okay, to indicate the number of such legends, we have to use the terms bis in place of di, tris in place of tri, and tetrakis in place of tetra. Right? So these will be the prefixes used, and also we have to enclose their names inside the bracket. So we were discussing writing the name of the coordination entity. I told you, first of all, we have to name all the legends that we have discussed. Now, after naming all the legends present in the coordination entity, what we have to do? We have to name the metal atom or ion. So for doing so, we have to see what is the charge present on the coordination entity as a whole. You can recollect that the coordination entities may be neutral entities, they may be cationic entities carrying a positive charge, or they may be carrying a negative charge. That means they can be negatively charged entities also. So if the coordination entity is neutral or it is carrying a positive charge, we have to simply write the name of the metal atom. And we don't have to use capital letter anywhere. We have to write all the name, whole of the name in small letters. Okay, so we will write the name of the metal as such. When the coordination entity is neutral, it is not carrying any charge. When the coordination entity is carrying a positive charge, we will write the name of the metal as such. For example, if there is a cobalt atom, we will write it as cobalt after naming the legends. If it is platinum atom, we will write the word platinum after naming all the legends. Then the second point is, in case the coordination entity is an anion, it is negatively charged. Okay, then we have to change the name of the metal. What we have to do? We have to put a suffix 8, ate, after the name of the metal. For example, if there is a cobalt atom, then we have to write its name not as cobalt, we have to write cobaltate. If it is a platinum atom present in the coordination entity and the coordination entity is negatively charged, we have to write platinate and not platinum. So you have to remember this, that in cases the coordination entity is carrying a negative charge on it, we have to change the name, we have to add the suffix 8 after the name of the metal atom. Then there is a note. There are certain metals whose name is written in Latin language. For example, If iron is the atom, we don't write iron. Okay, if the coordination entity is negatively charged, we will use ferrate. Okay, if gold is an atom, we will not write it as aurum or gold, we will write it as aurate. So what we are doing, we are using their Latin names. And if it is silver atom, we will write argentate. To remind you, you might have studied in the lower classes that the name of the iron, Fe, it is ferrum. The name of the metal, Au, that is gold, it is aurum. And the name of the metal silver, it is argentum. So we are using their Latin names. In certain cases like iron, gold or silver, we are using their Latin names. And if the coordination entity is negatively charged, we will put 8. So iron will be written as ferrate, gold will be written as aurate, and silver will be written as argentate. And after this, we have to write the oxidation state of the metal atom. Okay, now what is the oxidation state in the coordination entity? What is the oxidation state? It can be neutral, it can be 0, it can be 1, it can be 2, it can be 3. Now we have to mention the oxidation state of the metal atom or ion in brackets. After writing the name, again I am revising it, repeating it. First of all, while writing the name of the coordination entity, we have to write the names of the various legions in alphabetical order, and then we have to write the name of the metal atom. Okay, and after that we have to write, mention its oxidation state, and this we have to write in brackets. Okay, after the name of the metal, the oxidation state is written in Roman numerals. Supposing if I have to write 3, I will write 3 in Roman numerals. Okay, and this will be put in parentheses, that is in brackets. For example, I have given one example. In the case of this coordination entity, which is having a Fe atom and 6 cyanide ligands, and the charge is -4. Okay, now if you have a look, if you think carefully, now each cyanide ligand has got a negative charge on it, and if there are 6 ligands, cyanide ligands, then the total charge is -6. And on the coordination entity as a whole, the charge is -4. It means that the iron atom might be having a +2 charge on it. So the oxidation state of the iron atom must be +2. So we will write the name of the iron, that is we will write ferrate because it is negatively charged entity, and then in brackets in Roman numerals we will write 2 and we will close the bracket. This is how we name the coordination compounds. Now very important thing, when we are writing the names of the coordination compounds, we have to use small letters. In books you will find somewhere the capital letters are given. You may commit a mistake, so my advice to you is that you always write the name of the coordination entity in small letters, and you don't have to write them separately. That means you don't have to leave any space. Whole of the name should be a one word name. The names of the ligands, then continuously you should write the names of all the ligands, then metal atom, then its oxidation number, and then the anion. So you don't have to leave any space, and you have to use small letters, okay, so that there is no mistake. Okay students, now we will discuss certain examples for naming of coordination compounds. Look at the first example. It is K3, then coordination entity, right? On the right hand side, I have asked you to think. You have to think what is cation. So the answer is potassium. K3 is the cation. That means there are 3 potassium ions which are acting as cation. And then what is anion? So the coordination entity is anion. That is FeC2O4 whole thrice. And what is the charge on the anion? Now since the counter ions, that is the 3 potassium ions, they are carrying a +1 charge, that means the total charge is +3 on the potassium cations. the total charge on the coordination entity might be -3. Then we have to name the cation first. So we will write potassium. And you see, I have not used capital P. I have written potassium. And then we have to name the coordination entity. Now, while naming the coordination entity, I have to name the ligands first in an alphabetical order. But here there is no need of alphabetical order because there are 3 oxalate ligands. So I will indicate the number by tri. So I will write trioxalato. Why I will write trioxalato? Because sir, the oxalate anion, the oxalate ligand is an anion. It is carrying a -2 charge, -2 charge. So I have to change its name. I have to use a suffix O. So I have to write instead of oxalate, oxalato. So I will write potassium trioxalato, and then I have to write the name of the metal atom. Since the coordination entity is a negatively charged entity, I have to write the name of the metal atom as 8, and I will be using Latin name, that is ferrate. What I will write? I will write ferrate. So the name is potassium trioxalato ferrate. Now in brackets I have written the oxidation number of this iron atom, right? Since the charge on the coordination entity is -3, right, and the charge of the 3 oxalate ligands is -6, so iron might be having +3 charge on it. So the oxidation state of iron is 3. So the name is potassium trioxalato ferrate, and in bracket I have written 3. Similarly, let me discuss the second example. Now in second example, the cation is the coordination entity itself, and the anion is 2 chlorine atoms. So I have to, in place of anions, I have to write chloride, and before that I have to name the cation, that is I have to name the coordination entity. Now in coordination entity there are 2 types of ligands. 5 ligands are ammonia molecule and 1 ligand is chloride. Okay, so I will write pentamine, and please look at the spellings. I have written double M, pentamine chlorido. Then I have to write the name of the metal atom. Since the coordination entity is positively charged, so I will not change the name of the metal atom. So the name will become pentamine chlorido cobalt. And what is the charge present on the cobalt? Since there are 2 chloride ions as counter ions, the total charge on the coordination entity must be +2. Okay, and inside the coordination entity, ammonia molecules are neutral, but chloride is having a negative charge, so there might be +3 charge on cobalt atom. So I have written pentamine chlorido cobalt, then in brackets in Roman numerals 3 followed by the name of the anion, that is chloride. So pentamine chlorido cobalt 3 chloride. This is the name. The next example, please look at this. It is a cationic entity. It is carrying a 3+ charge. Okay, so when we name it, at the end of the name we will write ion, but we will write ion. Now if you look at this carefully, there are only one type of ligands in it. That means there are 3 ligands, and the ligand is ethane 1,2-diamine. Now the name of this ligand is ethane 1,2-diamine. It includes some numerical prefixes. So we have to write its name in bracket. Okay, when we are naming the ligand, we have to write its name in bracket. And when we have to indicate its number, we cannot use the word tri. Instead, we will use the word tris. So let us name the ligands. Tris in bracket, ethane 1,2-diamine, then cobalt. Now I will not change the name of the metal because it's a positively charged cationic entity. So the name of the metal will be used as such. So tris, ethane, 1,2-diamine, cobalt, and since ethane 1,2-diamine is a neutral legend, so the total charge which is present on the coordination entity, it is because of cobalt atom. So cobalt atom is having a +3 charge on it. So the name will be tris ethane 1,2-diamine cobalt in Roman numerals 3 and iron. This is the name. Okay, you can see that while naming I have not used any capital letter and I have not left any space. All the letters, all the words, they are joined together. Okay, then comes the last example. Now if you look at the last example, the cation is a coordination entity and anion is sulfate. So at the end of the name we will write sulfate. And since sulfate is having a -2 charge, the cationic entity might be having +2 charge on it. Let us see how. Now there are three types of ligands. Ammonia molecules, they are neutral. Chloride, it has a negative charge. Nitro group, it is having a -1 charge. So there are two minus charges because of ligand. But platinum, it might be having +4 oxidation state. That's why the total charge on the cationic agency is +4 -2 and it is +2. Okay, so the charge on the cationic entity is +2. So let us name them. So we have to write the name of the ligands in alphabetical order. This will then the metal atom, then its oxidation state, and lastly we will name the anion. So tetraamine, look at the spellings. There is a double M. Tetraamine, chlorido, nitrito N. Now why I am writing nitrito N? Because it is clear that the nitro group is attached to the nitro ligand is attached to the metal atom through nitrogen. So I have written nitrito N. Then the name of the metal atom as such, platinum, and then its oxidation state 4, and then sulfate. So the total name becomes tetraamine chlorido nitrito N platinum 4 sulfate. I think this is sufficient. Now you can work on nomenclature yourself. Please try to solve all the examples. Try to write the names of all the formulae which are there in your books.